Well, welcome back. Just to hopefully everyone had a nice lunch. This is a continuation of basically the precision technology session here. So for the majority of the afternoon, we're going to start in on a discussion more around not only PWM or pulse width modulation, but talk more about targeted spraying and where that may start to fit. That's probably been one of the more consistent discussions this winter. It seems like more and more people are kind of interested in this targeted spraying. And just to kind of highlight, I think we were at Agritechnica last November, and if you're in an OEM booth or had an OEM booth, or you were a spray company, you better had target spraying technology in your booth, or you're not keeping up with the Joneses kind of thing. So it's kind of here. There's a lot of questions around it. And so we're going to probably just kind of work through just having a baseline. So a few things. We're going to go here for a little bit. There's three of us that's speaking. I'll introduce Dr. Sharda here in a little bit, and then Jenna Elleman from AgPro will follow up and talk about the See and Spray. So I'm excited to have both of them on this discussion. So first up, you get to deal with me here for a little bit. So my goal, and I think all of our goal is just to bring awareness of what we're doing here. And the reason being is, we've kind of gone, if we go back in time, and we thought we had pressure-based systems, right? If you go back and remember those days, I set the pressure and then I had to maintain a speed throughout the field if I was going to be consistent on what I was trying to apply, in particular for crop protection. And then, 25 years ago, at least as I think about it, we moved into more flow-based systems, right? And so that gave us the capacity to be able to speed up, slow down, but adjust that flow rate. But that also had influences on the pressure, right? And that could cause issues if we were outside the range of a particular tip. And now today, in the last at least, AJ, I was thinking back, it's been probably 15 years we've been working on this, but you look at opportunities, pulse width modulation has become prevalent on a lot of machines today. And there's advantages to that. And there's advantages, I think, for crop protection. But my message today is when you start getting into this pulse width modulation and then make the jump to targeted spraying, you got to kind of walk before you run. You can't just understand that I'm going to buy, a See and Spray machine and not have to rethink about how I nozzle it, how I set it up, how I utilize it effectively for what it's going to do for me on my farm. Sure, it's going to be able to preserve or save me money on my herbicide, right? But if I'm using it incorrectly, I'm not going to be able to accomplish what I'm doing. And so that's the reason we're having this session today, is have that and kind of building through this. But there we go. So what is pulse width modulation? There's going to be some overlaps here to just get, but it's been around for a while. But when we look at even tractors, we look at sprayers, we look at fertilizer application, it's become more of a mainstay to control, right? It's a solenoid. I'll show you some pictures, as well, you can see on the slide here. And then we can open it, we can close it, we can do that in millisecond time if we wanted to, okay? And we'll get into some of that today. But it doesn't rely necessarily on pressure to regulate the system flow, but it can change. It can ultimately, PWM, from a sprayer perspective, I can control droplet size and I can control pressure if it's programmed correctly. I can accomplish some of those. And so what happens in this, we've been able to overcome some of the limitations. Back when we did pressure only, I had to maintain ground speed. Well, what happens in scenarios when I'm in a turn, or I need to slow down, or I need to speed up? I'm over under applying immediately. In a flow-based system, again, I'm controlling the flow rate. I got a flow meter, and it's going to control the pump or the pump pressure to account for that change. But yet there's some limitations even in that, okay, to maintain droplet size, for example. So if I get going too fast, okay, my pressure might fall out. I might be down to 20 PSI or 15 PSI. If I go too slow, my pressure might be exceeding where I want to be and operating outside of that particular nozzle. So there's some limitations. Pulse width modulation has its limitations, but in the context of trying to deliver product and keep a droplet size and a coverage that we're expecting, we can do it much more consistently within the range of its operation. Okay, so we overcome some of what we had in the past. So this is just what we see today. Again, this is out of Ag Leader. The nice thing is I'm showing you on the spray boom here, you know, with PWM, we're basically doing nozzle by nozzle type control, or have the capabilities. Let me put it that way. We have the capabilities to do nozzle by nozzle control. So again, using auto swath or auto nozzle in this case, we've already previously sprayed here. You know, it's turning those nozzles, individual nozzles off. And then those that where the areas haven't been, we're basically effectively, and for many of us, maybe be down at 15 inches control. Okay. So we've overcome this thing of being 120 foot. I'll use that, and maybe being boom section down to now we can control things on 15 or 20 inches, depending on how your spacing's set up. So that's kind of a set. So the benefits, these are the benefits as I see them. Number one, for some of you that have lived in this precision ag era, remember the days when it took us like 3 seconds to make a rate change. Okay, we had a lot of ball valves back in the day. With PWM, I can snap something very quickly. And so typically speaking, we're well under a second to make a rate change. Well, that's pretty important, considering when we're on a sprayer in particular, we're always going to have accelerations and deaccelerations, folks, right? Whether we're making a turn or when I'm going down the field, we're always going to be somehow not maintaining exactly 15.0 miles per hour. And with PWM, I can make that adjustment almost instantaneously to maintain what we're trying to accomplish or spray at a specific rate and droplet size. So it's very quick. Okay. As mentioned, we've improved control over the flow and pressure. Okay. We've spent, I don't know, 25 plus years thinking back some of the work that was done at UC Davis. We've been able to overcome, and with the right frequency, okay, and duty cycles to control these things, we've been able to maintain that droplet size, okay, and basically the efficacy of that product, regardless of what the conditions of that machine's being put into, like as I mentioned. So we do have individual nozzle control. We saw that on the prior slide. We'd be very precise. And then we can also do, if we so choose, is variable rate application. For some of you that may have not been around it, when we think about crop sensors, we put a crop sensor on a sprayer and we want to go across and we want to adjust our nitrogen rates, which has been done. In the past, it's taken 1 second to make changes, if not longer. And so what happens in a controller is you're just always at a deficit. You're just chasing where I want to be. Today with PWM and being at the nozzle, making that change at the nozzle, not upstream at the pump, I can make rate changes very rapidly right where we need them. Okay. And so we've overcome some of the limitations that we've had in recent years, up until recent years with this technology. Consistent spray pattern and droplet size. Again, kind of mentioned that. And then basically the other idea here is because of the technology and the feedback, I can actually monitor with the research that goes on around tips, right? The development tips. I better have feedback to you, for those sitting in the cab, what the actual droplet size is. So again, if we're out there trying to do a specific type of application, I need a very fine type of response out of that tip. I can ensure that I'm making that or accomplishing that today. And some of the monitors are giving that feedback to the droplet size for that specific type tip. And then ultimately is turn compensation. I don't think we have to go into that in too much detail, but when we think about Ohio and the number of 120, if not 90-foot booms that are operating in the state, we're constantly putting those booms, whether it's up and down or in a particular on a curve type path, we need to make adjustments. I think we're all in a situation tonight when we think about environmental impact, we think about drift and things like that. When we set that machine up with a specific nozzle and we want to accomplish that and minimize the environmental impact out there, PWM begins to allow that machine to accomplish what we intended with that across that large boom, regardless again of the conditions we're putting that large sprayer into. So those are where I see it fit. And where the benefits come in. And I think as we go on, as you start to see some of these technologies, we've moved into a scenario where I can buy these technologies directly out of a dealership, right? I can order it already. And in some cases, they are just coming. In couple cases, you're just going to get the technology, Okay. So we're moving in this path where I think you're going to see more and more kind of nozzle level opportunities for growers in the future have this access to this technology. So a little bit of overview. I'm not going to go into this. I'll let Dr. Shaw talk a little bit more about it. But all I want to say is that basically we put this solenoid or a solenoid typically on the nozzle body. In some cases, we're redesigning the nozzle body, but from a traditional nozzle body, I'll use T-jet. You know, and all we're doing is we got a plunger there at some frequency that goes in and out. Okay. And so it's open here and closed here. And so we talk all of a sudden, we put terms like this out. Again, you don't have to take this home and know this, but we start talking about things like duty cycle. Okay. Everyone in here knows what duty cycle is, right? By definition. Basically, that is the percent of time that's going to be open versus closed. So if I tell you it's a 50% duty cycle, that means it's going to be open 50% of the time, closed 50% of the time. And if I'm doing that at a frequency of 30 times per second, think about that, folks, 30 times per second, that means that thing's actuating 60 times essentially, but it's going to be open 50% of the time during that 30 hertz and closed the other 50% time. Okay. So this, my point in this is happening so quick that I would prescribe to you. You wouldn't even see it with your eyes. It happens so quick. That's how fast it's going. So I'm just saying 30 hertz. That's pretty typical. Not all is the same, but that's pretty typical, the frequency. And then for each of those cycles, I'm open 50% of the time, or I'm open 25% of the time, or I'm open 70% of the time, or I could go fully open to do kind of 100%. Everyone with me? Now, does anyone see any challenges with that? If I'm doing 30 hertz and that thing's just sitting there going back, what's the challenge with that? Inertia. Dang straight. We all of a sudden have this new thing. I'm just not open on that nozzle body all the time anymore. Now I've got this plunger. I got this inertia that I got to account for too, because it takes a certain percent of energy to open that thing and close it. But what else happens during that quick time? Boy, it starts pulsing the line, folks. Okay. So how do we account for that? My point in that is, in the past, we typically taken a traditional nozzle body that we're all used to. We take the little rubber thing off the side, or the cap with the rubber, and we insert this solenoid in, and all of a sudden we get this pulsing action. And that's not what it was designed for. Okay, that's not what we designed for. We had designed those nozzle bodies to flow, and then about 10 psi to shut off. And then we matched it with a nozzle at the pressures for that nozzle to accomplish a certain droplet size. But all of a sudden we get all this dynamics happening. As guess what I'm driving into is, and I just want everyone to appreciate when we get into the next conversations from our speakers, is there's been a lot of research to go on to this. This isn't a constant flow. All of a sudden we have this intermittent flow, all this inertia, and then all this pulsating going on. It's a lot different dynamics specifically on that nozzle than before. So that nozzle, if everyone's with me, will it behave exactly the same? So if I take my XR03 and put on there, is it going to behave as if it was fully open as an 03? Not at all. Total different behavior. And so we've spent years, I guess, trying to come up and deal with some of this resonance in there to try and make it more consistent, to accomplish or maintain the droplet size and pressure that we need to achieve what we're trying to accomplish out there. So just some thoughts behind this. I just want you to appreciate there's been a lot of work behind this to get to where we're at. So today, just to overcome this, rather than doing all nozzles all the time, we basically do this blended pulse, because if we're doing them all the time and we have this pulsing, there's going to feel like this intermittent where we're missing something. You're going to be on, off, on, off. And if you're traveling at 15 miles an hour, say, that you would feel there, and there would be a gap. Is everyone with me on that? So what we did is to overcome that, we came up with this blended pulse strategy. I think, as far as I know, everyone's come pretty much to this strategy, that we're out of sync 180 degrees to overcome that. So we're always spraying. okay, at all times. It's just that we're using overlap to accomplish the full coverage within this as well. So that's been added into to this as well. So just some things additional, and what I want to do is kind of talk to you a little bit about some of the commercial systems out there. But it's in my opinion, and what we've seen, as long as you're operating within in the limitations of the pulse width, and the companies are doing a good job to put literature out, in my opinion, you can accomplish both flow and pressure and meet the expectations for what you're trying to accomplish out there. So a few other things: nozzle selection. Okay. First thing on nozzle selection, okay? Number one, I've run in this in the last 2 weeks, whether it's Precision Planning or Deere or T-Jet or whatever, all the companies that put out new specs on their PWM type technologies to make sure you select the correct nozzle, okay? So for example, and again, this is probably the poorest example, but if you're using an XR03 typically to accomplish what you're trying to go out, you're going to have to put like an 06 on it now. It's going to have to be 3 to 4 times larger nozzle in order for the PWM to perform as expected in the similar fashion of what a traditional 03 would. So traditionally, you're going to have to be 3 or 4 nozzle sizes larger when you go to PWM. So that's totally different than how we've sized that. But the companies, all of them, at least have put out spec sheets to allow you to make sure that you're meeting the rate and the coverage that you're trying to accomplish over there. Okay. Operating outside the duty cycle. So again, the duty cycle is the percent of time on. There are limitations. Okay. This has to do with speed and then ultimately what we're trying to accomplish with the PWM. In my opinion, you don't want to operate under 20%. So if you're at your farm and all of a sudden are operating under 20%, you need to re-nozzle, as an example. Okay. Meaning that you get down and it gets so low, some people might even tell you 30% is the minimum that you need to run. But again, these operating in lower duty cycles will not be of value to you to meet the expectations of what you're trying to do out there in the field. Okay, so another rule of thumb, 20 for some, others would say 30% possibly, but that's 20% we use today. Everyone, you understand what I'm saying? If it's only on 20% or 10% of the time, you're out, you're that fluctuates. It's happening too fast. You can't accomplish it. It's overworking the system. You're not getting the results you want. Okay. And then operating pressures. Generally speaking, this is just an example that I put down. While lower pressures are generally used for producing coarser droplets in a traditional system, a PWM system operating at lower pressure can result in poor application performance. So again, there's understanding, rethinking how you're setting up your sprayer, operating your sprayer in here, going on nozzles, duty cycles, and then making sure that you're keeping yourself plenty of pressure there to get the flow through that PWM body to make this work. Okay, so just some kind of rules of thumb. Again, it's a rethinking of how we set the sprayer up to accomplish. So a lot of times we can go out and simulate. I'm going to run at 15 miles an hour. I can pick a nozzle to meet whatever I'm trying to accomplish out there as far as the droplet size and the coverage, and then making sure that the pressure, there's the tools out there to ensure that you try and fit this to what you're thinking about trying to run out there in the field. But again, my point is, it's not our traditional thought process is what's been in the past. So I'm going to skip over this for time. Okay. So last thing I want to do is there are several systems. I will not cover them all. I'm just throwing this out of the ones that I guess I get majority of my questions on. But here's kind of the list. T-Jet has one. Raven has their Hawkeye, which of course is now owned by CNH. Capstan's been in the market for many years. Okay. And if you use any of the case systems, those are all initially based on Capstan. John Deere's Exact Apply, Ag Leader's Right Spot. Precision Planning recently entered the market as well with their technology. And then, of course, the AIM Command, which has been around for many years. Okay. So those are just some of the more prevalent ones. And if you're interested, we can send you the links to learn more. But let's talk about a few. So Raven or CNH, the Hawkeye, was introduced in 2014. That technology provides embedded in it turn compensation, individual nozzle control on off. Okay, as of today. That's it. Okay. It doesn't it's not set up or they are working on it, you have to go to just a slightly different system if you want to do targeted. But if you want to use pulse width modulation, the Hawkeye gives you an option. These are the basically two functionalities that you get out of it, the individual nozzle and the turn. It is typically a retrofit kit. So if you're someone that's already has a sprayer, regardless of age, and you want to retrofit it, you could retrofit this, especially if you're a Raven type display user, you can retrofit this to your system. Okay. John Deere ExactApply, introduced in 2016, currently an option on machines. There are 3 modes of use. Oh, I should say it does individual nozzle control, does turn compensation. You can program rates. It's got a nozzle plug detection, so you can look at that. And there's some LED lighting too, as well as I saw off the website. But the point is, you can get several technologies embedded in this one PWM. It's got 3 modes, so just understand there's 3 modes that you can operate in: a high flow, an AB mode, and then in a true pulse width modulation. Okay, and now we're adding targeted spraying into this discussion as well. So that's a little different, but anyways, but here's an example of this. But in general, what they've done, which I think is different, is basically build a nozzle body. You fit 6 nozzles on that. And then if I understand, you can actuate 2 at a time is what happens in that. Okay, so a little bit different design than what your traditional other systems will look like, where it's on an individual nozzle body with an individual tip on it. So precision planning, at least this has been a lot of questions on is introduced here recently. So we're kind of going into the second season. Again, it's a retrofit kit, similar to what we saw on the Hawkeye. It will maintain constant pressure, okay, within the system. Does provide swath control and turn compensation, but you got to have a Gen 3 or newer 2020 monitor for it to operate. So you got to have basically one of the newer displays and for you to use this. So seems like there's been some interest from growers based on the questions I got for this technology. So, but it does do swath control, maintains pressure, and then gives you a turn compensation when you go around corners, making sure across the whole boom you're maintaining the exact rate. Then lastly, the Ag Leader, the right spot, similar to precision planning, introduced in 2022. Again, this is a retrofit kit. Okay, so if you're an Ag Leader person, you could bring this into your technology stack. Individual nozzle control, turn compensation. The neat thing about this is at the screen, you can actually monitor droplet size. So this in real time at the screen, you can actually look and see what your droplet size is. And so they can kind of look at that on the go. And that's another feature provided to the operator. There is some additional, what's unique about Ag Leader is not only does it give you some additional parameters to monitor, okay, while the spray operation is going on, but you can also capture some of that as applied data too. So if you wanted to go back and map a few things out of this, you could also do that as well. Not all of them are providing that feature as of today. So, but the nice thing is those give you individual nozzle diagnostics. So you can think about this, at least for those of you using the planting technology, I can kind of know how each row's performing. In this case, it gives you diagnostics for each row or each nozzle in this case to understand and have and go back and look at. So it also creates a boom pressure map, as I mentioned, as one of them. Again, you can create a map now of what the boom pressure was across the field. So again, just some more data to look at to verify what actually went out in the field. So those are just some of those that I get questions on. So before I turn on over to Ajay, why? I just think, as we think through this and what we're trying to accomplish, especially on large machines that are operating today for crop protection, we can improve droplet size control. Can be more uniform regardless of what we're doing with that machine or what that machine's put into out in the field. We can definitely improve resolution. We're not doing boom sections. We can do individual nozzles, just like we're doing individual rows on planters. And then ultimately, in my view, if you can begin to understand pulse width modulation, how to size nozzles, how to set it up, use it for your advantage, it's a step into the things like the See and Spray, targeted spraying technology out there. So with that, Ajay, you want to move up or start moving your way? We are publishing some of that information in the e-fields. If you want to see more, there's handouts in the back if you want to grab one of those books if you haven't had it. And then we're going to kind of wait till Jenna's done to take any questions after this session. So anyways, Ajay, you want to, Beth, you got that? 1 second. While she, but anyways, I'll let you introduce yourself real quick while we get to this. Good. Got to record these. There's an order to do. We're good to go. All right, Ajay, we'll turn it over to you.
Thank you, John. Thank you so much. Good afternoon, everyone. And there are some familiar faces from the last time who gave me a lot of hard time. Seems like they're busy right now on the computer. Maybe they'll get off. I'm Ajay Sharda. I'm professor in the biological and agricultural engineering at K-State. 10 years at K-State. 5 years with John Fulton and Auburn, finishing my PhD. And then a year and a half at Washington State University. So I talked about planters in the morning. Liquid application system is what we did back in Auburn when I was doing my PhD. Done some work, but lately picked up on a lot of things here. I did talk about the Institute for Digital Ag and Advanced Analytics at K-State. So just I'll share more information. I didn't put anything for this session, but great group of people who are doing a lot of interdisciplinary research. We typically see usually people don't come from all the different disciplines. When we talk about agronomy, entomology, and computer science, bio and ag engineering, and then we think about geography, geosciences, and statistics. So really excited about that that part in terms of where we are. So I'm gonna jump into the liquid application part of it. John did a great job in terms of setting the stage up for you guys in terms of where we are, right? And what I'm going to do is I'm going to touch base a little bit. I won't spend too much time on flow-based system, but I'm going to refresh some people's, some of our, memory in terms of, where we were on flow-based systems. What are some of the challenges? It's only challenges. It's not that we cannot operate. We still can operate, but there are a few challenges we cannot address them while we were on the flow-based systems. All right. So I want your participation here so that we can. Great. All right. So when we talk about liquid application, pesticide application thing, there are a few things which still are pretty familiar, right? Any magazine I've picked up in the last 10 years does have some mention of pesticide resistance. Have you guys noticed, felt like that, right? Where do we get new resistance areas or new areas where we are finding weeds which are resistant hardy? In the field, middle of the field, edges of the field, on waterways, right? So some of the places which do show up some of those things are places where we go in and out, right? Every time we go in and out of the field, somewhere where they are making rapid, application, flow changes in terms of sprayer part of that. Drift has been the basic, major thing, right? I don't know. We've seen some dicamba thing in the past. We had lots of plots which got damaged, and drift is still a concern, right? We can go long distances from where we are, and all of the things like right place, right time, product label. Right? I believe everybody reads and follow the product label. Yes, can I see some show of hands? Yeah, people are pretty reluctant in showing that, but no, we're talking about nozzle selection, we're talking about speed, droplet size, and application rates, and so on and so forth, everything, right? Then it comes to damage and timeliness part of it. We want to do things in a time, when time comes and weeds show up, I just want to be in and out and make sure I can cover all the acres. That's the goal, right? So these are some of the things which are still out there. We're trying to address all of those things. I'm pretty sure there are lots of new products in the pipeline, which you will probably see this year, next year, which will, add to our knowledge of, what's going on. And there are a lot of things, from a technology standpoint, advancements, and all that stuff. So I use this slide in most of my presentations, and I think it's one of those slides. If you can get by this slide, then we can sit down and see what are the things on a flow-based system, and what are the things which are on the on the PWM system. When we go through few of those things. So from an application standpoint, or anybody who's people run sprayers here themselves, yeah. So what do you expect from those sprayers? What is when you buy a $500,000 sprayer, what are your expectations? What should it do right for you? Everything, right? Right? He's just saying, what are you talking about? That things some go wrong? No, there's nothing which is wrong on those sprayers, right? So we expect everything which should be right on them, right? So let's put some of the things in perspective, and then we'll go through from that part. Number one thing is we all expect the application rate to be accurate. Not constant, not stable, but accurate. Wherever I am on the field, it should be accurate. Is that fair to say? And I want that to be right, whether I'm running straight passes or curvilinear passes. All does make sense? Yeah, both ways. I don't want that it should be only accurate when I'm making straight passes. The other thing I also expect is that I should be able to rapidly go from 6 miles to 20 miles. Oh, no, sorry, that's a lot of speed range. Should not be doing it. No, right? Well, I don't know. Speed changes. When a lot of speed changes happen, I rapidly ask my system to, scale back on, system flow rate to make sure my application is right. So that should happen all the time. Another thing is we're going to start talking is what John laid out, the foundation for that is we were talking about application rate to be accurate on a boom by boom basis, right? That's what flow-based system boom control thing is. We're talking about we should be having right application rate on a nozzle by nozzle basis, right? That's what my expectation is when I buy a technology like that, which can do all of those things. These are my expectations. Are we good on that? Right product flow rate all the time, straight versus curvilinear pass, from nozzle by nozzle, one end of the boom to the other end of the boom. Good. Is that a fair expectation? Yes. Okay. All right. The next expectation is, which is more important, right? We have spent almost the last decade and a half trying to nail and figure out how to maintain product flow rates all the way up to the nozzle point. The next most important point, and next most important thing we need to really address, the elephant in the room kind of a thing, is the coverage aspect of it, that I should get all the product down to where I need to get it to. That is plants, not my neighbor's field, not on somebody's pond or somewhere else, but on my own field, right? So when we talk about coverage, what are the things, we need to be cautious about? Number one thing, when we read the label and we pick up a nozzle, there's a component of droplet size aspect of it, right? So we need to have, and that is John touched base on that part as well. We need to have nozzle selection and everything so that my droplet size stays consistent, right? In a flow-based systems, what happens when I speed up and slow down? Pressure goes up and down, right? And if I do not have a right nozzle, or if I go like a crazy guy like me, who can go from 4 miles to 20 miles, I can be anywhere from 20 PSI to 80 PSI. And what my expectation is that I should always stay medium droplet size. Is that going to happen? No, that's just, it's just not possible, right? So droplet size is number one. And it is all related to pressure. We do have some variable orifice nozzles, but I don't think those are very popular. They were in the market. We used them for a little bit, but they're just not a very popular choice right now to be put on our sprayer, right? If I have a variable rate, orifice nozzle, then I can do something about it. So if I want to maintain my droplets, I want to maintain my droplet size. I don't know. I don't care how. I don't care how, what the system looks like. And then the other part is the overlap aspect of it from the boom, standpoint. That's fair and square. And the other important thing is boom height. right? From our sprayer where we are in terms of we've gone from 60-foot sprayers to 120, 135-foot boom sprayers are pretty common, right? Are they pretty common here? So, and our booms are pretty stable all the time. You can go up and down the terraces and speed and all that. Our booms are stable all the time. Is that okay? Right. That was the point to make, that we have a lot to expect from those booms. Any change in boom height, not any change, a couple of inches, fine, but a lot of boom movement happens when you are out on the field, both horizontal and vertical. And when we talk about spraying, when the booms are moving, it's pretty amazing to see. The other thing I want to point everybody's attention is when we look at overlaps and everything, when you go to TJ, Hypro, any companies, they change the boom height, which goes up and down like that, right? And we are looking at overlaps, we're looking at coverage issues and everything. But this is how my boom moves on a sprayer. No, that's not how it moves. It moves like that. And suddenly it changes the angle of my orientation. It changes where the product is putting out and how much product can actually go into drift mode very rapidly and very quickly. And there can be instances where there are some areas which are not getting any product, right? So that's where the boom height control, boom management, comes into play. I can maintain my good droplet size, but at the end of the day, if I cannot maintain the boom height accurately all the time, it has significant effect in terms of how much product you will end up having in your own field versus somewhere else. Good with this thing? Everybody's on the same page. All right, the last thing is, minimizing drift. We're looking at, nozzle selection, John mentioned, boom height, and obviously environmental conditions. We'll talk about wind. We live in Kansas where winds are just always there. 20 miles, 15 miles, 30 miles, and I can just wait forever and be patient of not going out and doing anything, but it's just not a reality, right? So what do you do? I don't think there are any many options we have, but that's just the reality from that standpoint. All right. So with these things in mind, keep in mind all of those things, what we have laid out. Is there anything which you're missing? Anything comes to anybody's mind that there are more expectations from a sprayer or a crop protection system? No, Paul? Jenna? Good? Okay. So from a liquid application standpoint, lots of things are there. There are standard things. I love this picture. This was my very first few years in the US, and sitting in a machine with so many things which are out there. It's just fascinating to see it. And we all rely on this guy here, continue to telling us that a lot of things are pretty good, right? So all of those technologies pretty standard. John touched base on the flow regulation aspect of it, and we are trying to maintain flow within the system. That's great. And the requirement of the system is to do things rapidly. I also want to point out very, very quick that we can pick up any of the system, even which is 2023 model flow-based system, right? The basic requirement is still the same. I want rapid flow changes, and rapid flow changes happen because of two instances. One, when a lot of substantial portion of my boom shuts off, whether it is overlap, whether it is no spray boundary, previously sprayed areas, whatever the case might be, right? And the second thing is when I rapidly decrease my speed or increase my speed, rapid speed changes, and there can be huge things when both of these things combine, right? So these are some of the case studies, way back in the days from a flow-based control system, right? And it pretty classic, but they are still true, right? These are two fields, one more like rectangular field, other is a much more irregular field. We're talking about, and I'm putting a context because we're going to go back in the PWM arena and we're going to lay out completely different rules, and see how far we have come along in achieving the good kind of a flow management from a nozzle by nozzle basis. So plus or minus 10% is all green dots. Everything which is yellow and red is over application. Anything which is blue and purple is under application, right? So what do you guys think on it's standard sprayers, industry standard, fully calibrated, farmer's field operation. So what do you guys think from how did the sprayer do on the left on a rectangular field? pretty good, like lots of nods, hands, nice and clean. I get in the field, I maintain constant speed. My boom was fully on all the time. I was able to maintain my application rate within 10%, right? So 10% is a good range. And if you talk about plus or minus 10%, that's it's a good bit of a range. I got some issues in terms of getting in and out, which, ramping up the flow, but that's fine. What do you see on the right? Right, lots of things, right? It's a pretty, I think this is one of the most difficult fields we have ever sprayed. Because you can see lots of fields, whether either there are terraces or there are telephone poles or there are sinkholes, and it has all of them, right? And I also tell this story to a lot of my people back home, and that I was sitting on this sprayer with a full, kind of a desktop system in a sprayer. And this guy, who was a high school kid, was flying over the ditches at 30 miles and then 20 miles and then talking to me. And I was telling him that, can you please pay attention on the road? I don't want to get killed on my first adventure on the field. So it was a fun time learning that. And you can see that in some of these passes like these, he was flying at 23, 24 miles per hour, right? I made that trip. I'm still here. Now, this is another map from a farmer's field, brand new 2014 sprayer, and then it has 54,000 data points, and then even with this sprayer, with operator driving within 5 mile of speed range, we still have lots of product application issues as well, and primarily because of lots of sections going on and off, right? So we won't spend time here. The other thing I want to quickly say is the problem is that this is don't get bogged into this. This is time here, flow rate here. This is my speed, which is my gray line. The green line is how the required flow rate changes as you speed up in the headlands. And this blue line, not the blue line, but the red line is what the actual flow rate does. That up until it was crossing over the headland, it just doesn't know what happens, right? And it was all said and done before anything can be done. So what I want the term to be sent out is controller response concern. Means that it takes a lot of time to ramp up the volume, fully pressurize the tubing, stabilize it, and then get my pressure constant going all the time, right? Any change in that, I have to redo the whole thing all over again. The other thing we learned from this thing, and I think there are a lot of people sitting here in the room who were part of this project, Scott and John, and when we look at this data, we thought that we did something very wrong, right? We were looking at a couple of fields. We were looking at what percentage of the time we sprayed within 10% error. It was pretty minimal, right? We were like less than 30, 40% of the time we did a good job. And then a lot of time we were either under applying or over applying the product, right? So which is even true to today's point, that we do more under application than over application if errors are happening. And those are some of the reasons where we start to see those issues about, herbicide resistance and all that part. The last thing I want to share is the component of droplet size that I just can't. So we talked to, so giving you a similar context with like I did with the planters and sprayers, all of this work, whether it was past and present, is all farmer, field scale. We work with a operator from a co-op, because we want to apply real product and all that. And we sit down to lay some ground rules and all that. And his name is Billy. I asked Billy, I said, Billy, what speed we should be? This is what the speed is. This is what I want to do. This job. And we joke around and say, so do you guys maintain these speed ranges, right? And his obvious question to me is that, are you asking this question off the record or on the record? I said, what I'm asking is, what do you do normally, right? So when it comes to doing co-op things and when it comes to covering acres, speed is just there. It's a factor, right? So on a flow base, and the reason I'm coming down to that part is that if speed is that kind of a factor, you will have application pressures which are so wide. I don't think you have a nozzle in the market which can maintain that kind of a droplet size all the time, right? So obvious, we're not saying you can't do it, but it takes away the flexibility from your hands and asks you to maintain certain things or ask us to maintain certain things to make sure that we are doing the right things. The other thing, I'm not happy that there is something on there, but quality of data, like quality of job thing aspect of it, right? What type of confidence we have on the quality of data logging and display? What do you guys think? Do we have a really good data available when we are spraying? A lot of things to learn. Is it there? Not there? Are you guys happy? Do you need something more? Maybe, maybe not. Okay. So, say it again. Well, we are not even co-ops is a completely different thing, right? So I don't think co-ops will ever share that data with you, because if they share that data, you and tell you which speed they were going and where they were going with what kind of wind speeds they were, I'm not going to hire them the next time. True. Well, I'm talking about I'm sitting in a sprayer versus I'm sitting in a planter. What kind of confidence I have on the data I'm seeing, right? I don't know. I don't have too much confidence in what I see, right? Because when you saw these maps, you were sitting in the cab, and the data which was shown to me was saying, "You're spot on, man. Just don't stop, keep going." And this is what we saw, right? So that's what I'm taking your mind and needs as a customer, as a user, all of us, to say, okay, what kind of a data logging? What's the quality of data logging we have? What is the trust in data we have? Especially from a crop protection standpoint. And then obviously, what flexibility operator has. What does that system tell me to do certain things where I can really maximize the efficiency and productivity of the system? Can we communicate? Hey, slow down, man. This turn you're making at this angle, half of your nozzle is going to be beyond the speed you can ever maintain anything. Right? Can we get anything like that? Or do we get anything like that? So this is something to think about. So from some of the things from a flow-based system, challenges, overlaps, right, off target, whether it is overlap or no spray boundaries, that's something, because we have boom level control, not anything else, right? My whole boom has a role to play in it. This is the most important thing. The next two things. One is off rate and turning. Can I maintain that on a flow-based system? I just have one flow meter, one controller, one everything, right? What I'm going to do is, for everybody else, somebody will get a lot more and another will get something very less, right? But this is what I have to work with. And the second thing, which is from my standpoint is the most important thing, is controller response. It just takes forever to get to some place and stabilize. And the speeds with which we want to operate that system, we have very little time to make those adjustments. I'm talking about milliseconds. And if we need seconds to do something, we just won't be ever there in terms of what we want to get to. Agree with me? Yes, no? Okay. So we always talk about, we just can't throw our flow-based systems out, right? And I don't know. So there are some co-ops which are very actually reluctant right now to not move to PWM systems. Do you guys know why? Anybody wants to? So anybody has a flow-based system? A lot of people, right? So when people have flow-based system versus PWM system, like John mentioned, and we'll talk about it, it's going to put some stipulations on how you drive. And it will have a huge impact on how fast and how quick I can get the job done. It's not the report anymore. I really want my product to be on the field, right? So that's some of the things, but these are some of the things, manage application pressures as much as you can, speeds and all that. You can read, you can take a picture, but this is what we need to do if you want to really make the maximum out of our flow-based system, right? Do certain things in a certain stipulations. All right, making a switch to PWM systems, right? Don't talk about the pulsing aspect of it, duty cycle, frequency. And one thing I want to, share, we won't talk anything about it. It is that most of the systems up until when John Deere's 30 hertz system came was 10 hertz systems. Do you guys know that, right? So Hawkeye, Capstan, Raven, everything was 10 hertz system. So we'll just keep that in mind, and everything else was 30 hertz. This is a nice plot here because a lot of people get confused in terms of making the flow rate change at the nozzle level, right? We have taken everything away from the entire system and put a flow control thing right at the nozzle tip. All I need to do, like John said, we need to change the duty cycle, and I can increase or decrease the amount of flow based on what? Speed, right? So we'll talk. One take-home message I would like you to take here is that when we were in flow-based system, we were constantly fighting to get the flow to a point for that speed. Yes, right? Everybody with me on that? But when we are moving to PWM system, the only one thing I need to know to make a lot of good things happen is speed of each nozzle. If I can accurately measure the speed of each nozzle, I can implement the duty cycles fairly quick. And we'll talk about it. I'll show you lots of data that beyond that point, these systems are pretty good, to get the right, things in place. So when we're talking about rate changes, higher duty cycle means longer open duration of open times within that cycle, not more cycles per second. Cycles per second is still the same. So a lot of people get confused with that part. This is I stole this from Sean Flatch from Capstan, but what he was trying to show is that, with changing duty cycles, what you really do is you change the amount of volume being put out per unit time while still maintaining the application rates, right? So we started some of this work back in 2015, and we have a small mule. It has a 13 nozzle setup, all Raven system and all that. And we did some very quick and dirty things, right? I'm trying to put some confidence in your mind. My whole job here today is to, if I can put some confidence in your mind that, hey, X, Y, Z things are done right on these systems, then we are good, right? At least you will have to, you'll know what the system has to offer. We did this study where all of these colors are telling like how many nozzles are on and off, right? From when we were doing flow-based systems, we turn 80% of the nozzles off. You're going to see a very much elevated pressure in the system. It'll take forever to diffuse, and it'll still not come to the right pressure we were, right? That's one of the things, pressure deviations. So this first set of data was very helpful for us to really have confidence that you can have any number of nozzles going on or off. The rest of the nozzles will stay at a good needed pressure all the time, right? Plus or minus 5% error. We were talking about plus or minus 10% error in the past, right? So that was a huge confidence builder saying, hey, we need to do some more work, or we need to understand these systems much better, because we can maintain pressures tightly irrespective of how many nozzles are on and off. Does that? Oh, yep. Okay. So going forward, we were pretty fortunate to get hold of a couple of sprayers. We have 120-foot, sprayers, good or bad. These are all blue or red sprayers, all Raven system Hawkeyes. We have very variable fields. We go out and select fields which are just very, very difficult to work with, right? Tight corners, lots of point rows, lots of terraces to continuously slow down, speed up things, irregularly shaped field boundaries, whatever you can expect from a field, in terms of difficulty, so that we can understand and learn what is going on. Typical application rates, 12 to 15, and pressures and all that. Nozzle bodies, all XR, T-jets and all that stuff. Water, So this is these are some of the two maps. I think on the left is like some 70 acre field. Very nice. We've been working with this farmer for a long time, and it's just a beautiful field if you really want to understand section control and turn compensation and how many times you have to turn back off and all that stuff, right? This little corner here on the northwest side of it, and there are terraces, there are tight corners. It's just people say, I just don't want to be in the field again. This field on the right, it looks like one field, but the ditches in between are just so deep, you just can't go from one field to another field like that. You have to go around. But cumulatively, this field is another 140, 160 acre, field. Now, thing which John talked about, that when you select a certain nozzle to apply a product at a certain pressure, these are the two things which will decide that you will get a speed range you can drive. The upper range is absolutely topped off, because beyond that speed, you will be 100% duty cycle. You go faster than that, you're going to be under applying. You can go as fast as you want. All that looks great, but it's going to start showing on your map under application all the time. The lower side depends on what duty cycle you would like to maintain, right? I can throw a link to the publication, or I can share the publication with John, but we did some simulation work back in the days, right? We lots of things went into that, but we actually tracked every single droplet, whether it was 200 micron to 1200 micron, 2 meters per second speed to 10 meters per second speed, and where it goes and all that stuff. And we found out that, you have to be in that 40-ish%, duty cycle range to really get good things out of it, especially when we were in 10 hertz. So we have decided all of our lower speed limits to always stay around that duty cycle. You can go 30%, your speed range will increase more. You can go 20%, your speed range will go even more, right? But these are our speeds. And that is where a lot of conversations with Billy, happen. And, he just he's not happy. He's very natural to quickly go beyond speed. And then you have to remind Billy that, Billy, we cannot go faster than this speed, right? All right. To quickly lay out some of the things, what you're looking at, we have done a lot of work back in Auburn and here to know that pressure in a boom can be measured by putting pressure transducers in one or two locations, right? You can put a pressure transducer to the very end, to the T, or wherever in between. You can get a really good estimate of what the pressure is. So 5 boom sprayers, we put 2 pressure transducers on every boom. You are tapping on the CAN bus, collecting data as fast as we can. We exactly know which nozzle was on, which nozzle was off. We were always also tapping on all 36 control sections. That means I can give you a true map, or this map is showing you a true map of what every single nozzle was doing on that 120-foot boom sprayer. Put with me on that question, yes? 36, right? Say that, what is TP? So CPU is one, but there are control sections. How many control sections you can have, right? So, or control channels you have. In this case, there are 36. What happens is the outer are one, on a single nozzle. Then they start to pair, and then there are some which are 3 nozzles together. Now, with the control section is that it will always maintain one duty cycle. It will all be either on or off, right? There cannot be that in one control section out of 3 nozzles, one is on, or one is going at. It's pretty amazing to see the data that how can you maintain duty cycle 73.16586? I don't know. One brain, yes, right? So if I can tap all one nozzle from each of those sections, I can know whether they were on and off, and what was the duty cycle for each one of them. Does that make sense? Right? So we were tapping on all 36 of them, and what you're seeing is that all 36 channels are being mapped simultaneously. So it's not point data, it's 36 point for every pass of a sprayer. So that's why what you're seeing is that whatever is happening on the inside, outside, middle nozzle, whatever the case might be. Now, we got flow meter, we got GPS and all that stuff. Ultimately, what we want to see is one thing to start with: how consistent your pressures are all the time, right? So this is a nice field, what you saw here. But in this field, if you saw these parallel lines, there are terraces. Every time you go up the terrace, you slow down. You go over the terrace, you speed up, and then there's another terrace. There are terraces all over the place. And we have done some work to understand you can apply across or along, it doesn't matter. It's the same way. So the other part is, so you're looking a lot of, colors in there. The green color represents, in terms of pressure, the flow rates, which will give you 5% accuracy. So green color represents that pressure, that if I stay in that pressure, my flow rate error will be under 5%. That makes sense? The next color is 5 to 10, and everything else is beyond 10. So we have come a long way from understanding within 10% to under 5%. So what do we see, from all of these, not these two fields, numerous other fields. We have all the colors, all types of field and all that for a very high percentage of the time, you are within 5% error of flow from managing pressure standpoint in all these fields. If you're on a nicer field, which is a little bit more flatter, less terraces, you can reach up to 94, 95% of the time, right? So that's a huge plus from where we were in constantly going up and down on pressure and all that stuff, right? That's number one learning from that standpoint. Questions on this thing? Anybody? No? Okay. We saw similar things what we have been seeing in the flow-based system. Pressure below target. When you're accelerating and things are coming on, and pressure above target when you're when you're slowing down rapidly, all that stuff. And then these are some of the fields. Obviously, when you see rapid acceleration and deceleration, these are some of the areas which will show up, and now you can see how the field is in terms of what it is. What you see from so this is just a little blown up image of of that map. If you see that little corner here versus here, you come down on a certain corner, you turn fast enough to you swing your boom, and you will see that there are some little gaps there in terms of how fast the boom moves, right? I've shown you, and we've talked about a lot of green color. What do you see on that little corner, which is highlighted here? So when we were moving that fast and I was pretty much pivoting on a point, a lot of nozzles on the inside were barely spraying anything, and that half of the system was not doing anything while everything was still on. So I did see some elevated pressures on the far end of the nozzles because those were the people who were trying to spray something, and then a lot of product pushing in their part. But apart from that, most of the time what you see is a very good pressure consistency. That's number one. So one take home message is that you can speed up, slow down the way you want. Your pressure will stay consistent up for a very, very high percentage of the time in any field, right? The other thing, when it comes to making sure that your product flow rates are consistent from one nozzle on the left side of the boom to the 73rd or whatever 90th nozzle, is that all of my nozzle, it's not about one nozzle, it's about every single nozzle. So what we did in this is, like we said, we did coefficient of variation, right, on planner, like how good the seed spacing is, right? So we were looking at how good the pressure consistency is from nozzle to nozzle standpoint. And what we saw here is that for good 96% of the time or more, your pressure COV is less than 10%. What does the COV mean? That if you are within 10% of your coefficient of variation, all of your nozzles are within 3 psi of each other, all across the boom. Isn't it pretty cool? Right? Unbelievable, right? To some extent. Well, we've done some crazy things when we were in Auburn. We used to buy some good pressure transducers, and we used to put them on random places. We used to pick up random transducers to use, and man, they were pretty good, right? If you buy some good stuff, you can get some good data from that as well. So this was a great thing to learn, that every nozzle from one end of the boom to the other end of the boom is consistent in terms of pressure. You guys want to ask why this is important for us? Why do we want to see this kind of a thing from a pressure consistency standpoint? Why is pressure important to us in a PWM system? Right. Pressure is a thing. I ask my system to maintain some pressure, 40 psi, 60 psi. I'm basing everything out of that. If pressure changes, the system doesn't know you've gone from 40 to 60 psi or 45 psi. It's going to still maintain the duty cycle based on knowing that you want to maintain 40 psi. That's why we are talking, it is very important to have consistent pressure, right? The other thing we won't go into details too much is that there is some sort of a pressure drop across a nozzle body. You guys, we all understand that, right? And that pressure drop is consistent or not consistent. So that pressure drop is not consistent based on your application pressures and application rates. You apply at 60 psi and 20 gallons per acre, you apply 40 psi and 12 gallons per acre, the amount of pressure drop is different. Do our systems take into account that? No, they do not take into account right now. So there is no way to input. I don't know, maybe there is something in the back, but to my knowledge, there is no automatic pressure drop compensation to take account into. Right. So that is something another to think about. Good thing in terms of what we apply and all that. It's just not. It is significant, but not that part. So when we talk about pressure, so we going back to our needs for application rate accuracy. If I can maintain my pressures right, I can implement my duty cycles. I can have good product application from nozzle to nozzle because every nozzle by itself. And if I choose the right type of nozzle, and the right type of nozzle I'm saying is that if you want to apply at 50 psi, and you want to maintain medium droplet size, I would like to pick a nozzle which will give me medium from 40 to 60 psi. I should have a good range of pressure beyond, on the lower side of the pressure and then the higher side of the pressure, so my droplet size stays consistent. You choose a wrong nozzle, you may have that problem, but if you pick the right nozzle, you should be in a right spot. So you will get a very consistent droplet spectra, from what you're looking at. The other thing I would like to talk, which John mentioned, the ability to apply on corners, turn compensation. So these are some of the fields where we sprayed, right? When people spray and we spray, we just don't know for how much time do you need turn compensation actuated, because we just think that it's only needed for 5%, 10%, 15% time. But depending on the kind of field you have, the kind of field boundaries you can have, you can be spraying on different types of fields with lots of turn compensation needed for a very high percent of the time. So PWM system, a natural flexibility. It will automatically maintain your duty cycles to give you the right product rate, irrespective of where you are on the field. Makes sense to everyone? Yes? Okay. So very high percent time needing compensation definitely increases with irregular shape fields and all that. So we've talked about rate. We talked about something from the flexibility standpoint, curvilinear, straight passes, and all that. Coming down to the coverage component is that when we talk about PWM systems, we just cannot put that 2-inch by 2-inch card or a 1-inch by 5-inch, 8-inch strip at random locations and learn how good the coverage is. Can we? No, because the idea is we really want to map the whole on and getting on, staying on, and off cycle. That is only when we can get that. The other thing was all of the systems were 10 hertz systems, right? Why 10 hertz? Why not 50 hertz? Why not 100 hertz? What is the right thing, right? There are some systems in Europe which are that fast. It's just crazy. And then John talked about the whole inertia thing and the mechanical component, the damages and all that stuff. So we really wanted to understand, the difference in coverage and coverage uniformity was the goal. We wanted to see if you do these things. So we got 2 sprayers. We have absolutely exact same things for these 2 sprayers. Spacing, nozzle type, speed, height, you name it, right? There was no difference in terms of what those sprayers have. And what we did to do that is that this is basically a 2 feet by 2 feet board, right? So there are 4 of them. So if you combine all together, and if I spray something on top of those water sensitive cards, I can be moving at 16 up to 16 miles per hour, and I will have at least a couple of on and off cycles complete. And I will also be able to see at least 3 nozzles overlap to look at how good the coverage is, right? Second thing is we did not do any replications on that, because even if you come 5 minutes after that, any environmental change, wind speed, boom can still move differently and all that. So we considered that each individual 2 feet by 2 feet board is my one replication. Is that fair to assume that part, right? So we have lots of area to cover with. And once we sprayed with different duty cycles, and so you can see 3 different duty cycles, different frequencies and all that stuff, we bring it all together and we divided all that composite image into 2-inch by 2-inch, sections, because we want to see how uniform the coverage is on a fine ground spatial resolution. Yes, right? The card may look really good, but how uniform the sprays. And then we run some analysis, and it gives me, the lot of different things to look at. So these are some of the results in terms of coverage uniformity, average percent coverage area, that's the APCA thing, and then standard deviation. How much was the standard deviation in coverage from each single 2-inch by 2-inch thing? What do you guys see in these two things? Right? So you can still see some of the complete. So cycles go on, right? This is where the cycle went on, stayed on, and then back off. So when you see there is a peak, you have some high concentration of product versus back and forth thing. You can still see some of those things in the 15 hertz system as well. But if I show you something which is 20 hertz and 30 hertz, what do you see now? Like naked eye cannot tell anything, right? And even if you look at the percent coverage, which is 17 and 16%, hardly any difference. And then you have a standard deviation aspect of it, right? So from what you see in both of those, I think the higher frequency system, which is basically number of pulses per unit distance, it all comes down to, right? That's how you start to blend everything together in terms of getting uniform coverage, right? So I think most of the systems, all Raven systems are now 20 hertz, right? And I think 20 hertz system gave you the right kind of coverage, uniformity, very, very comparable to what 30 hertz gave you. So all the systems which are higher frequency systems are probably going to give you better coverage if you want to go that way. Questions on this thing? Right. Okay. Now the next. So we talked about that. We talked about the one coverage aspect, which is pressure related, right? Kind of a duty side, frequency of the system and all that. Now, boom height is definitely number one, on top of the list. And this is not an easy thing to kind of figure it out, right? Lots of boom moment. So what we have done is that we wanted to build a computer vision system which can give you an accurate horizontal and vertical movement of the boom. So this system is giving us under 2 centimeter of boom movement in any way you would like to do all the time. And what we want to do this season is we want to go out and really capture the extent of boom movement aspect of it, and we want to overlay with in terms of the coverage aspect of it. So, and what we will get is, and what we'd like to share with you guys is the extent of coverage quality you are getting within certain fields, right? And we'll go from there in terms of where we are. This is just one quick example of a horizontal movement thing. And I think in this case, the sprayer started from headland, the boom moves backward, kind of moves a little bit, and then it stabilizes where it is in terms of spraying. There are 2 data points which are overlapping. There is one data which is being extracted from a computer vision system, and then there's another data point which we have a really high frequency inclinometer, which was giving me the data. And I think at some point we are completely confident that the computer vision system accuracy is way beyond than the system itself. The last thing I want to share is wind speed aspect of it, like we just talked, right? I think there is some question about, do we have wind speed sensors on our sprayers these right now, right? Some people have. and others don't, right? And if I have to start logging my system, I still have to have a little, anemometer, check what the wind speed is, write somewhere down. Why can't the system have it by itself, right? And then where should I put it? What is the most representative location in terms of giving the right wind speed, right? So what we did, we just picked up 3 different locations to mount these wind speed, wind temperature sensors, very lightweight. And then so what you're seeing on this inside in this circle is that because there are 3 of these wind speed sensors, so one pass going up and one pass going down. So another thing is we started we typically spray on Saturdays and Sundays. This is how our operator is available, good or bad. But we started when the wind was almost south, and in a matter of 2 hours, 3 hours, we were blowing northwest, northeast, right? So what do you guys see? So all those red greens are, I don't know, yellows are under 5, 8, 10 miles per hour, and blues are more than 23 miles per hour. So what was my speed going north? 3 lines on the left. And what is my speed on the right coming down, against the wind? All right, nobody wants to say how much the speed was. There was a lot of difference. What are you saying there? What will it do to coverage and the product what you're applying? You guys need a break? Coffee, water? So, blowing it off target, right? So what Paul is talking about off target means any place which is not my crops, right? So it may go somewhere, neighbor's farm, neighbor's pond, neighbor's house, wherever, I don't know, 2 miles down the south, wherever north, or 10 miles, who knows? So this is just a reality. We can try to spray crosswinds, but can I trust winds? Who knows? After 2 hours, wind may start blowing in a different direction. And sometimes it's just the field is like that it's just not feasible to spray it in that way. That's another limitation from that standpoint. So this is where we are. I want to take you guys to take few things, take home. One, very consistent pressures, irrespective of your speed, irrespective of which nozzle you're talking about. Consistent droplet size all the time. That's right. Combine that, I can maintain these 2 things a really good, level of what I want to do. In terms of coverage, boom height, yes, there are booms which are just need some more work. I think this will be the area which will be, advancing more in the coming days. And I think wind is the thing which is the environmental component part of it. This is something I want to talk about. Another project. This is a little kind of a spot spray thing from one of our NSF products. We're really excited about where this product is now. It can go under canopy. It has a very, very robust system. Means like, we burned a lot of motors. We have damaged a lot of product, but I think this is where we are in terms of, it has a fully integrated system from camera vision to look at aphids, detect aphids within the plant, spray on them, collect all the data, put the data on the edge and on your tablet real time, right? So we're really excited about that. And you can put any kind of technology stacks on it. It means you can ask to detect nutrient deficiency. You can ask any fungicides or you fungus or insects or whatever you want to do, right? You can put that. You can start counting number of years. You can start estimating the yield of on sorghum plants. You can start counting kernels. I don't know what you want to do, right? So this can do a lot of different things. Really excited about it. So this is where we end. Thanks to these guys for a lot of support and questions if I have time. Otherwise, there'll be more time later on.
So is that spray too, Ajay?
Yes.
Robot?
Yes.
Question for Ajay while we switch over here to our third presenter. Comments?
Do you have much experience with like the green seeker technology as far as varying greater measuring?
I do not. We did some, I think, John did some work back in Elleman. I think he may be able to.
Yeah. What's your question about the green seeker? So the question was, do we have any experience with the Green Seeker, which should also be like the Optiv RX, and then Yara has a system / Topcon has a similar system. So when we did that work, the challenge was that the sensor itself basically gave an update to the controller about every 1 second. Okay. And back then we had all these flow-based systems, not the PWM. And so what was happening is we could do a pretty decent job to change rates with that going 12 to 15 miles an hour. But we were always chasing because you're always getting the next one and it's trying to adjust. So you get in a scenario where you're never hit, we were never hitting the target rates that we wanted to as far as nitrogen application in corn and wheat. Does that make sense? So if you advance forward to today and we redid that with PWM, where we're actually controlling it not with the pump speed upstream, right? That's what I essentially indicating, but bringing that control to the nozzle, it should be able to better, once you get a rate, hey, I need to be 10 gallons an acre or 20 gallons an acre, for example, it can make that change within almost milliseconds versus never being able to meet the rate out there. Is that your question? So, yeah, that was our biggest challenge. We never could meet the rates out in the field. So we'll turn the floor over now. Jenna Elleman's here. She's a technology lead for Ag Pro in the north up here. And asked her, as we talked about the PWM, we're kind of transitioning now to what more of the hotter topic is today is what we describe as targeted spraying. So we asked Jenna to come and talk a little bit about the See and Spray technology, which is commercially available today from John Deere. So Jenna, thanks. Hold on. Beth, are we good to go? All right. Thank you.
All right. As he said, my name is Jenna Elleman. I'm the Regional Integrated Solutions Manager for Ag Pro. Really glad to be here, be able to share about this new technology that's out with all of you today. So over the next 25, 30 minutes, hopefully here, we're going to kind of go through what is See and Spray, do a brief machine overview for anybody that hasn't seen it, kind of talk about some benefits, some example use cases we might be seeing with that, and then really kind of dive into some of the details about the current offerings, system limitations, and things like that. So first of all, what is See and Spray? Has anybody seen it in the field yet? No? Okay. Maybe. So it is around at some different locations. So we are finally going to start to get some of those units here into Ohio locally. So excited about that opportunity, but it's kind of one of John Deere's first sense and act solutions available. So what that means is we have cameras that face forward on the boom. There's 36 of them on a 120-foot boom. And then the ultimate solution uses 11 processors, premium would be 6, and then makes that decision in a split second to spray that weed behind it. So we want to be specific. This is not a spot spray. It is a targeted broadcast. So any nozzle that can contribute to the weed that it's seen with that camera will come on in this system as it is currently. So that system makes that determination whether it's weed or crop within 200 milliseconds. That's about a third of the time it takes you to blink your eye. So pretty fast from that vision processing unit, scanning about 2,100 square feet per second, and it can detect weeds as small as a 1/4 inch tall and a 1/4 inch in diameter. So think about, kind of a pencil eraser, if you will, size weeds. So pretty impressive system. So hopefully, we'll see if I can get it to play. Just a quick little overview. that video. I think it gives a pretty good overview of the system in general. So split tank, this is kind of the premier solution. This is the ultimate solution. I'll talk a little bit also about a couple of other offerings in the See and Spray space that John Deere has available, but that would be your premier system where you can make that broadcast application and that targeted spray at the same time. So why would we want to use See and Spray? So 4 main reasons here. We have improved weed control. Obviously, we're facing a lot of different resistance issues, more of those starting to move into Ohio here locally. Reduce that solution use. That's a big part of it, right? Gain cost efficiency. Maybe you don't necessarily care that you're going to save money, but you can reallocate to a more aggressive tank mix, something like that. And then your sustainability and stewardship. So improving that weed control, getting rid of that resistance as much as we can, not spraying in areas that we don't need to, kind of reducing that, some of those target weeds up there maybe that we're all starting to see around the fields here in Ohio, that are becoming an issue as we look at that. So maybe we want to look at doing a more aggressive tank mix. Maybe some of the products that we'd like to use don't get along well in the sprayer together today. And this gives us more options for what we can do with that moving forward. Reduce solution use. So this is a little bit dependent on what system it is from Deere that you're going to use. So Select is kind of its own little thing. And then you have Ultimate and Premium. So Ultimate up to 67% savings, 54% on the Premium. I think those are the two that we'll probably see the most of in this area. So along with that, you're going to get those maps about what it is that you're saving. What was your target rate? What areas did you apply or not apply? So that's just a little screen grab down there from one of their sample fields out in one of the I states. Gain cost efficiency, obviously your spray volume reduction. So this image on the right here, that is basically a picture of what the camera sees when you're spraying. So those pink rows, it's identifying as the crop row, and then the red is the weeds that it's seeing and that it's going to target for that spray application. That is the highest sensitivity, so that's something you can do in those machines is adjust the sensitivity of what size weeds it is you want to look for. So there are a couple of other options that may not have picked up a couple of those smaller weeds in the picture as well. Sustainability and stewardship, obviously, you know, we're talking about H2 Ohio earlier today, some of those things, maybe there's opportunities in this space in the future for that. So using less herbicide, you're going to reduce that risk for drift. And then there's a couple other things you can look at on the See and Spray side in terms of what is your nozzle fan angle. That will impact your savings, as well as what boom height are you running at. So there are some limitations on the boom height that you can run with See and Spray. So we'll talk about that a little bit as well. But that lower boom height will make that targeted application more precise as well. So how do you know when you're in the machine, you've set it up, you're running your sprayer, what does it look like? So monitoring on that display, you will get 2 separate maps, and you will also get these in Operations Center. I've got a couple screen grabs of that as well. But that as applied rate, so anywhere that it's gray is where that sprayer boom has covered, but it didn't apply because it didn't see the need to. Anywhere that it's green is where it applied that specific target rate that you have input into the sprayer. On the bottom half there, that is a weed pressure map. So think about that like a yield map for weeds. So where it's green, there's not as many weeds. When it's red, there's a lot of weed pressure in that area. So we see that a lot. Green is good, red is bad. And then you also get an as applied percentage counter down there at the bottom. So that's giving you a % of the total area where you applied or where you did not apply in that machine. So you also get those maps in Operations Center as well. So this is your applied rate on Operations Center. So again, that gray is where you covered with the boom, but you didn't actually make an application. The colors there will show you your actual as applied rate. You can customize that legend in there. And then you also have Monitoring and Operations Center. This is your weed pressure map. So again, green is where you don't see a lot of weed pressure. Red is more where you see that pressure. So you can see these both on board and off board the machine. So, and maybe you use this weed pressure map to say, okay, maybe I need to go back and make a second pass in those areas, or I need to, you know, check those specific areas. Maybe that gives you some more agronomy insights on that side of it. So See and Spray use cases. So like any good agronomy question, it depends, right? So that's what we always say. There are a lot of different intricacies to this system. So it kind of depends. What's your current chemical program? Are you willing to make changes to that to make it work with the system as it is today? do you want to prioritize chemical or cost savings, or are you going to simply reallocate those resources and be more aggressive in those tank mixes like I talked about earlier? So I think we'll start to see some other use cases coming up for this in the future as we start to get some more local data. Lots of different opportunities maybe in that space. So now a little bit more into the details of what's actually out there for the different deer systems outside of kind of the generics. So Select, like I said, is kind of its own system. So Select is a green on brown solution that's only for fallow ground. I don't know that we'll see very many of these in Ohio because a lot of our machines do both fallow and in-crop applications. So probably not the best fit for us around this area. And that is a single tank system, factory installed only. Then we have Premium. So that's our retrofittable solution. In model year 25, it will also have a factory install option for select Hagie models. Right now, that is only on John Deere machines, 2018 and newer. There are a few other kind of precursors there, such as you have to have the improved boom track capability. So that boom height is very, very critical for these cameras, as well as that exact apply technology for that individual nozzle control is kind of a precursor to this system as well. So if you have a machine, even if it doesn't have exact apply, we can upgrade that. And that is an option for the Premium. And so that will also leave you with a single tank system. So it's a little bit trickier maybe to find some use cases for this, because if you're combining any of your residuals with some other sort of pass that's more of a contact pass, you may have to go back and make 2 passes if those things are antagonistic and you can't put them in the same tank mix. So keep that in mind. You know, if you want to broadcast and see and spray at the same time, the Premium's not the best option for that particular customer. And that's when we would look at going to that ultimate system. So the ultimate system is what I showed in that quick little video there. That is a factory installed solution only right now. Carbon fiber boom, boom track ultimate, those types of things all come with that ultimate system. And so that dual tank system, so there's 2 options for the tank split. So depending on what size tank, you'll either get a 650/350 split or a 750/450 split. So that smaller tank will typically be your see and spray tank, and then your bigger tank would be your broadcast tank if you're going to do both of those at the same time. Any questions about that part of it? No, it's a little bit confusing. So, you know, it's a great system, but there are some limitations to it. It's like we've talked about all this afternoon, different speed limitations, crop limitations, things that we can do for PWM systems, which see and spray actually is not a PWM system. You can PWM out of the front nozzle when you're broadcasting, but that back will be sized based off of your kind of flow systems, if you will. So for the Premium, it's 12 miles per hour maximum speed. Ultimate, it's 15 miles per hour. So maybe co-ops aren't going to spray in that range. So, you know, we need to look at some of those things, see if there really is a return on investment for some of those situations. Minimum crop height, so corn greater than or equal to V2, soybeans V1 bigger. It's compatible with cotton as well. We have any cotton growers in the room? Good. So those are kind of the minimums, and then the maximums. Basically, that crop height has to be under 16 inches. So that's another big limitation right now. I know they're working on trying to increase that, so there are some additional use cases there. But basically, once that canopy starts to close and the camera can no longer see that weed, that's when you start to run into issues with the system as it is right now. So in the future, maybe we'll have cameras that can kind of go down under the canopy and scope it out, and we can kind of target that way. But for now, this is where we're at. Row spacing, you can do 30-inch or 15-inch soybeans only on the 15-inch, but 30 inches. And then you can do cross row up to 30 degrees on soybeans as well. So a couple different limitations there on the see and spray side of things. So things to consider, you know, when are you typically making your passes on those crops? Does it fit into that current system? Or are you going to maybe change it up a little bit if this is something you're looking into? Couple of other limitations that we've run into as we've started to kind of price these out and look at different operations is no nighttime spraying. So you're going to get your best performance 30 minutes after sunrise up to 30 minutes before sunset. So maybe some changes coming to that in the future, but for now, that's where it's at. Also not compatible with direct injection, just because we talked about needing pressure at the boom all the time for this system. So that is not compatible with direct inject. And then Mobile Weather and Connect Mobile are not compatible with the system currently either, if those customers might be using that. Now the big question, what's the cost structure, right? That's always the next question. You talk about the great system, well, what is that going to run? So the See and Spray cost structure right now has two components. So you have that upfront hardware cost, whether that's a factory install or field install, that will vary some. So that would be something we want to look at in an individual kind of situation basis there. Because like I said, you may need the upgraded boom track system. You may need to go to Exact Apply. There's a few other things there that will go into that too. But and then we have a per acre license unit. So that currently is for every acre you cover. So for fallow ground, it's $1 an acre. For corn, it's $3 an acre. For soybeans, it's $4 an acre. So that is what it is for model year 24. And we got some concerns, I guess, around this just because it's a little bit of a gamble, right? If you're not going to save enough spraying a particular acre, you're probably not going to want to leave that system on. You're going to say, why would I pay for this if I'm not going to save at least that much as I cross over that acre? So what will be coming for model year 25, and there's still not a lot of details around this, but it has been announced at Commodity Classic, is that they're actually going to change that per acre fee to be based off of the acres that you did not spray. So the acres that you actually saved on. So that way it's not as big of a gamble when you take that sprayer out across the field. You know that you're only going to pay for where you actually save instead of having to evaluate that risk. So right now, just to throw an example out, so we are offering the See and Spray Premium Kit is $25,000 installed. So that's that upfront hardware cost that we can put on those 2018 or newer sprayers. Now, depending on what you have, if you don't already have Exact Apply, you don't already have Boom Track Pro 2, we may have to add some additional costs into that as well. And then, you know, it's kind of up to each individual dealer whether they will install that kit or Deere now has actual mobile install crews that will come out and install that for us. So we're going through our first one at Ag Pro right now. Actually, they're putting it on today down around Lebanon. So it's been a good experience for us so far to have that Deere crew come out, and we'll see what we get for results on this premium system. Why the license fees? I saw some smirks, I guess, across the room when I started talking about that a little bit. So the idea is that it's a lower upfront costs, right? So we're going to reduce that barrier to entry for that technology. You know, if you want to use it, we don't want that cost to be the barrier for you. Only pay for what your farm needs. So everybody always asks, well, how can I scale this? You know, I only farm 1,500 acres. I only farm, you know, 2,000 acres. What does that look like for my operation? So we're going to scale that to what it looks like for that particular farm. And then the other thing is it gets better over time. So you might have noticed in the video for Ultimate, it talked about 12 miles per hour. Well, they came out and said now it's 15 miles per hour. When it was originally released, it was only 30-inch rows. Now we can do 15-inch rows. When it came out, we could only do width row. Now we have software updates to go cross row up to 30 degrees. So that's where those license fees come in for those particular reasons. So some resources available, I'll just throw these out here. Really, because there are so many different intricacies with these systems, really recommend you contact your local dealer to learn more. So we do have some return on investment calculators that are available. So as long as you know your chemical costs and your application rates, we can kind of sit down and run through that scenario, see, you know, will it pay, will it not pay? You know, we've seen a lot of the corn applications that are generics, we don't see a lot of benefits on, but some of those beans we're running a little bit hotter of a mix, maybe it does make sense. So we can run through that ROI calculator there, and then follow Ag Pro on social media. So we're going to have a couple units out running around. We'll have a demo unit this year as well, working on some events around that as well. So if you're interested in seeing it in action, please, you know, check us out. We'll be posting that stuff as we get those events planned and lined up, and hopefully sharing some of that anonymized data on a local level too.